Guys, so today I'm going to take you through my second lesson or my second video on files. Yeah, so previously we spoke about files and I took you through how to manage files from the low level. But then the disadvantage of that is that you have to manage your own buffer. But then thankfully, this library, the standard library, provides us with an abstraction on on the low level handling of files by providing us with file streams. So in this video, we are going to talk about file streams and how they are used in C programming. Now, these are the things that I want us to talk about. There are more to look at, but I don't have enough time and I don't want the video to be too long. So I've taken particular functions or topics that I want to cover in this particular video. So let's talk about the first thing on my list, the file structure. So what we see here, you can see that we have a file structure, right? So I want us to use a GDB to explore what it is. We can also use the debugger that the debugging extension that VS Code provides us to do it, or you can just use GDB to do that. I prefer the GDB, so I'm going to use it to explore what we can find out inside the structure. So what I'm going to do is I'll declare a structure. Let's call it a file stream, and then so it's a file stream is basically it's similar to what we did earlier in file descriptors, just that this is a structure. So we are going to call an FOP, which is like a constructor that creates a file object, a struct object for us. So what we are going to need inside is the path to the file, but then my file that I want to create in here is a file inside my current directory, so I don't need to specify the path. And then I pass the mode. Now this time, in our previous lessons, we were passing integers for the mode, but in this time we pass a string that specifies the mode that we want to pass. So we have different modes. We have, you can find out about the modes from here. Let's say f open here. Oh, sorry. So man f open, then we have that. Now when we look at this, you can see we have a lot of modes, right? We have the read mode, the read plus mode, which opens the file in read and plus. We have the write mode, and then we have write plus, append, and then append plus. So these are the modes that we can have, right? And they are equivalent modes in what we did last week is given inside the manual. So we can see from here, read corresponds to read only, and then we have write corresponding to write only, or create only, or truncate, and so forth. Now, what it means is that if our file doesn't exist, when you open it in the write mode, it will automatically create the file for us. But then I've created a file which contains, let me delete the content of the file so we don't have, or let me even delete the file as a whole. So let me see if I can remove that file. So let's say, yeah. So now that this file is deleted, let's see what will happen when we we run our program. So first, I'll run the program by passing the debugger symbol to it so that I can debug it. Now I'm giving a warning that I declared a variable, but this is not really a problem. This is just a warning. So I'll go ahead and then run it with my debugger. Now let me clear everything and then start from here. So now I've opened my file in the writing mode. So I'm going to run my program. Now let me set a breakpoint at, let's say, the return value 7, so that I'll break at the line 7. Now when I run this is giving me this, right? So now I'm hanged at run. Now let's explore what the struct is, what it is about. So we can use the print and then print out So when we print fs, you can see it's a pointer to the file structure. Now let's find out what the file structure is. We can do that by typing ptype and then ptype, and then we can type by fs. Now this is what it's giving us. Now the type, as we mean, it's this type. Now this is the structure, the file structure. Now my file that we have over here is an alias for this structure, right? So it's an alias for it. That's the reason why we can use that. Now you can see that the type of this particular variable is of this structure, a pointer to this structure as it is indicated over here, right? So these are the fields of the structure. And also the important, we have structures, the IO read pointer, then we have IO read, and what they are is, you can see that we have for write and read, right? So the reason why we have these two is because we have the buffer, the IO buffer. So we can have the base of the buffer and then the end of the buffer pointers to them. Now if you want to find out the size of the buffer, we can use these two. Let's try that and see. So we can print, let me print, so we are going to find the difference between the pointers to the end of the buffer and then the base of the buffer. So how we can do that is we can do fs and then we say base, I think IO base. These are not really mostly, so and minus fs, let me see, IO have style or base. Okay, so base. This is giving us 0 because we have, I think the buffer is a dynamically allocated buffer. Now once we write something to the file, this will be updated. The reason why we are not getting anything is because our file is empty, so we don't have any buffer corresponding to our file, right? That is the reason why we are getting it means that the base and then the end of the buffer is the same. But let me add another line, then recompile and then see if we can get. So let's try and write something. Let me create a buffer here. Let me create a string. Let me say character. Then we are trying to a string equal to, let's say, hello world. Hello world. Then we have a new line. Let me say. Now let's say we are going to write that too. So we call fwrite, which I'll talk about later. So string. Now we are passing size of character. So that's it. So what we are passing is sort of an array of characters, which is also a string, right? And then we want to specify the size of each element in that array, and then we pass the string length of that array. Let me see, string length of string, and then we will pass the where we want to print or where we want to write it. Now when I compile this one, let me see, I have clear, and then I open it with GDB. Let me set another breakpoint to, let's say, line 10, and then run this. Now when we print the f, what we did earlier on, I think we should get something different now. So we have IO, and we have end minus IO graph. Then we have the base. Yes. Sorry, so I'm supposed to write something. Oh, supposed to be fs. So let's say fs. So you can see now we have a buffer allocated, which is 4 kilobytes, if I'm not wrong. Yeah, 4006. So yes, so that's the buffer that we have right now. So let's play this. Yeah. So we can print the once more. So we can print the buffer once more. So in earlier on, I printed the pointer, but what we want to really do is to print the actual structure. So we do this and then we print the actual structure. So you can see this is the file structure. Now inside the file structure, we have a lot of fields, right? So we have the IO read pointer, which points to the buffer, the read buffer. You can see that it is having the hello world, which we are trying to read to the file. And then we have the IO read base. So the same thing that we have here. Then we have IO write pointer being set to null pointer. So that's what we have for the meantime. I'll talk about how write also works in this video. So yes, and one of the important fields that we should also take note of is this, right? This that we have over here, the file number. So the file number is basically the file descriptor of the file that we need. So basically, we are trying to abstract this, right? Building on it, providing it with different fields to store its buffer. Now on my list, I have a section that is dedicated to discussing what a buffer is. So I'll talk about that later. Yeah, so you can explore and then find out more about the file structure. Right. So let's get to the next inline. Yeah. So what I didn't add here F close. So this is also very important. I forgot to add it. Now let's talk about the next thing in line. So I've already spoken about fwrite. I used it over here. So what fwrite basically does is that it helps us to write to the file. So what it initially does is that it writes to the buffer of the file. That's the reason why we can see here that we have hello buffer, hello world inside our read pointer buffer, and then we have the write buffer. So and then the read, they are all pointing to the same pointer. They have the same pointer, which is the beginning of the file. If you want to verify that, you can verify by printing the read buffer or the buffer of the file structure. Now that's what we had earlier on in here. So you will just print the base of the buffer and see its address. So you can see that the base address, which is the address of the first element in the buffer, which is this one. Now the reason why it's showing you this one is this is done by GDB to show you that it's pointing to some string, right? Yes. But then what it's basically telling you is that the read pointer is pointing to the first character. Now the end and then the read pointer and then the read end both are the same pointer. So when you're trying to read from the file, it will give you an invalid. The reason why this is done is because we open our file in the write mode, so we can't read from this file. So if you try to read from the file, it will return nothing because the read pointer and the end read are the same, so it reads nothing. Yes. Now we have the read base also, which is I think the same thing. They are all equal. You can see the addresses are equal. Now we have the write buffer, which is what we did right now. We wrote to the buffer. And then you can see currently what we are pointing to is nothing because we've successfully written to it now. Right. So it's pointing to an empty string and so forth. Now, at this point, you remember our instruction is now hanging at return. Now return, let's open the file. Let's open the file and see what is going on in the file. Let's say manc, for example. So code example. Now when we open, you can see that the file still has nothing to it. Doesn't have anything here, right? The reason is because when you write, that's the difference between the file stream and the file descriptors that we discussed in my previous video. So the important thing here is that when you call the fwrite, the operating system doesn't, or your program doesn't invoke system call directly or once. What it does is that it stores what you are trying to write inside the buffer, right? The buffer of this tractor. Now, you need to manually flash that buffer, or you have to call close. When you call close on this, it will automatically flash what is inside the buffer into the file. Or if you don't do that, when the program terminates, that's when you return from the program and you terminate from the program. The operating system automatically cleans up, so it will do that for you. But you can manually do that by flashing the buffer, right? Flashing it. So you can use FF flash, yes, to flash the buffer. So you can do that. Or you can just call close on the file also. You can call close, F close on file stream, which is IFS, right? So that's what we can do about it. So we can do this to flash the buffer inside it. So if I want to do that, I have to recompile it. But then I also said when you terminate your program, it means that the buffer will be. So we haven't terminated yet. Now we've returned from the main function. Now after returning and exiting the entire program, so we can see we've exited the main program. Right now, when you type configure process exited normally, you see now after exiting, you can see that we have hello world inside here. Right now, we don't want to do that normally, so we normally want to close our file or flash the buffer before we return. So I'll show you how that will also work. So let's delete what we have over here for the meantime, and then we will quit, and then we say, and then we will recompile this. Let me recompile this, and then we have GDB. GDB, and then we have this one. Then we break at, let's say 11, and then now let me break at 10 rather. So let's break at 10. And when you run this, before the F close, when you look at this, you can see there is nothing in the file. Now when we run the F close, you can see that's happening. We have hello world inside our file. So that's basically the advantage that the file streams provides us. The reason why it provides us this advantage is that sometimes writing directly from memory to your hard disk or drive is slow. So you don't want to be doing that all the time. So what you want to do is that you want to buffer it. You want to store what you're trying to write to the disk. You store it in a buffer, in a very big buffer. Normally we use 1 kilobyte buffer or 4 kilobyte buffer, as you saw earlier on. So you buffer the data. Now when the buffer is full, it automatically flashes to the hard drive, the disk, right? Or you can manually flash it by calling the F flash. So we can also do that. I'll show you how the F flash also works. Or you can close the file, and then closing it will also cause it to flash. Alright. Or you can leave your program to terminate. After terminating, it flashes to your drive. This is synonymous to, let's say, so I always give this analogy. Let's say you are in a certain room. You are supposed to move, let's say, papers from that room into an office, right? Now, there is one way that you can do it. One way that you can do is that whenever you take a paper, send it to the office. Whenever you take the paper, you send it to the office. Another way that you can do that is you can put a box in that room. And whenever you get a paper, you put it in a box. And then wait till the box is full. Then you send the entire box to the office, which is a little bit far from where you are or from that room. Now you can see that picking one and sending it to the office at every time is very slow in the end. Rather than putting them in a box and then transporting them at once. That is very similar to how the buffer also works, right? So that's basically what we are trying to do. Yes. So now that we've done that, I think it's the same thing with the read. That's why I've taken my time to explain it with the write, with how the buffering works. Now let's say I have F close and then I have F flash also. We can do the same thing, and then you realize we have the same output. So let me make this one and delete this, and then we can recompile, and then we have GDB. We break out, let's say 10, and then Yes. Now when we run flash, you can see it's also the same thing. Yeah, so basically that's it. So just like when you are writing to the disk, you want to buffer it. When you are reading from the disk, you can read an entire block of memory, which is very large, and then put it in a buffer in memory. And when you want to read again, when you want to call read again, you don't directly read from the disk, but then read from the buffer because you buffered part of the file inside the buffer inside the RAM. Yes, so I hope that's about the reading too. I won't talk about it because it's similar to how the write works. But then if you want to read, what I would like to point out is that you have to open your file in the read mode, and then instead of writing here, we can call read. And then instead of having this, I think everything here will still remain the same. But then the string will have to be a buffer, right? It will have to be a buffer. So let's call that one a path of size, let's say 1024. Then now when we read from the file, we are going to read everything from the file. So let me call this one path. And then now we know the size to be 124. So we are going to read, if let's say the file had a lot of let me repeat this copy. Now you buffer the entire of this into a buffer, right? You read everything that is inside the file into the buffer, right? You read everything into the buffer. Now let's see how that will work. So let's say we compile this and then we do gdb, then we run that, and then let's break out. I shouldn't have added the flash because now I'm not trying to write to the file, so I don't need to flash the buffer, right? Yes, so we flash the buffer when you're trying to read to the file, but then this time I don't want to do that. So this should have been closed. But close. And now I'm going to, so even now I'm going to run this. Let me break out, let's say 11. Oh no, let me break out, I think 11 is fine, or 10. Okay, let me break out 10. So break out 10 and then run it. Now when we run this one, now we read from the buffer, so we can print and see what is in the buffer. Now let's print buffer and see what is inside. So you can see we have this in the buffer, right? Everything, the hello world, number of times in the buffer. So that's how it works. Now imagine if you had wanted to just read a line, right? You don't want to be calling read all the time. So what you normally do is that you want to buffer the entire file inside RAM. So you call read once to read the entire file into a buffer. And if you want to read the first line in the file, you just read the line in the first line. Just read this line, right? And then so forth. So that's how it works. And the next on our list is close, which I've already spoken about. So you have a fair idea. It sort of cleans up the file, right? There. It cleans up the file. Now get line. So get line helps us to, I won't talk about it now because I don't have enough time. But then what get line does is that it does something similar to the read. But then what it does is that instead of calling this, we call, let me show you how it also works. So what it will do is that it gets, let's say, get line, and then so I'm coming. I think get line is supposed to be part of this. It's not in the, so it's supposed to be here. I think I already have it already. Let's see, get line. Alright, so get line gets us a line buffer. Your line, so right. So let's say I want to store that in my buffer. The car, this one, I want to store it in this buffer. Now what I do is that I now have line pointer. Oh, sorry, not line pointer. Sorry. So I'll have the size. So I have to declare another variable, or let's say which is of size t. Let's call it length. Let's call it 0 at first, and then we pass the pointer to that. Now what this does is that it stores the number of bytes that we stored in the buffer. Okay, so that's what L does, and then we pass the F string to it. So this just reads a line, right? It reads a line. So we can run that also and then see what's happening. So normally what getLine uses that getLine uses a dynamic how do I say it? A dynamic array, right? So I'll pass this to it. It will allocate a memory to it. Now, because it's going to allocate a memory dynamically for buffer. After using this, you need to free it, right? You need to free the buffer. So let's say after closing the file and I'm done using this, I have to free that buffer before I continue my program. So normally this is what you do when you're using getLine, right? So yeah. Now we can have GDB to inspect what is going on in here. So I'll break at, let's say, 13 down, alright, 9. Now let's see what is inside buffer. So you see that buffer is now containing hello world, which is a dynamically allocated memory, right? If you want to find out if it's actually a dynamically allocated memory, what you can do is that you can use what we you can inspect memory. First, you can use info to find out about your program, right? So we can say prog, then the mappings of our program to see what is going on in our program. Now you can see that in here, when you look at the heap, see the address ranges from here. Now you can compare this address. You can see this address is inside, it's in between this range. So basically, that variable is a dynamically allocated variable because it is on the heap, right? Yeah. So basically that is it. Now after that, it means that after using this one, we close our file and then we have to free the buffer. Otherwise, it will give us a leakage, right? Memory leak. Alright, so that's all about getLine. So the next thing on the line or on our topic is fseek. So fseek also helps us to. So fseek, just like lseek in our previous video, helps us to set the current pointer to the where we are trying to read, where we are reading from the buffer to wherever we want to read. For instance, I said in my earlier video that let's say when you create a file descriptor, the operating system is currently pointing to the beginning of the file. Now when you read a line, it's now will be pointing to the where you read up to. So the next read will read the next line, and so forth and so forth and so forth. So if you want to set that pointer to the beginning of the file, then you have to manually use lseek to do that. Now fseek helps us to do the same thing, right? So I'll just show you a scenario so you can find out more about fseek using the fseek command. That will show you this. So it takes in the where you want to start from. So we can start from, as we said in our previous video. I hope it's here. So we can start from the beginning, the end or the current position, and then offset to the byte that we want to write to. Now let's assume that I want to start, but then I want to just print hello world. I want to read just hello world. So what I can do is that before getting the first line, I'll first set, using fseek, I can set. Now I take my fs, I can set to. So you know hello is how many characters? Is it 5 characters plus a space means 6 characters. So we'll offset. So that's the offset, right? Offset by 6 characters or 6 bytes to be particular and to be precise. And the reason why I was using characters is because characters are also 8 bytes on my system, on my platform. So 6 bytes from the beginning, right? And then starting from where? Starting from I can start from the first, from the beginning of the file, so that I'll just read my hello world. Now if I do that and then I come here and then I recompile, I use GDB to carry to it. I set a breakpoint at, let's say, 14. 14 should be enough. Then I run this. Now after doing this, I can print buffer and see what is inside buffer. So you can see it is only board and then a new line. So basically that's what the fseek. You can use that to do a lot more. You can set the pointer to whichever location you want to set it depending on your reference. So this helps us to this is like the base reference where we are standing in. This is the offset, right? So we could have, let's say, started from here and then offset to, let's say, here, and then still have the second line read and so forth. So you might need that when you are trying to read and manipulate files. And this is way faster than, because the fseek doesn't directly work with the disk. It's rather interacts with the buffer, the buffer of the structure. So you know that the structure has a buffer which is buffering whatever is supposed to be stored inside the file. So basically we'll be working in RAM rather than working directly with disk. And when you flash, everything goes to disk. So now let's get to the next, the rewind. So the rewind also helps us to bring, it's just an fseek, a special form of fseek, but it brings us back to the beginning. So it's something like this, but then the offset is rather 0. So bringing ourselves back to the beginning of the file. That's the rewind. Yes, and then ftel tells us our current position, where the number of bytes. So let's do that. Let's say I set the position to, let's say, 6. Oh, I can even find out that from here. So let's hope we can. Now what I want the ftel. Okay, so when I come back here and then I use ftel. So ftel then fs, so 12, right? So the reason why it's giving us 12 is because now we read this. Now when we count this, the hello word plus the new character should give us 12. That's what the ftel is telling us. So it tells us this is position. Now when we are reading, we'll read from 12 going, right? Which is the next H, which will be the next character after the new line. Okay, and that is clear enough. And then now let's talk about the type of buffering. Now I said that the ftel, the file structure, the file stream, we call it file stream, right? So it buffers data, but then it can buffer data in several ways. What I use over here. So one of the ways, first of all, it can use unbuffered. Unbuffered simply means that the buffer size that you have is 0. So whenever you are trying to do fwrite, it directly writes to the disk, right? And also you can use line buffered. Line buffered is telling the compiler that whenever you are reading or you are writing to disk, right, and you come across a new line, the new line character, the current buffer of the file stream should be flashed to disk, right? And also we have the fully buffered. The fully buffered is also telling us that we wait till the buffer is full. Now when the box is full or the buffer is full, we flash everything to disk. So I think, so we can manipulate that, we can change that, the setting. So if you are interested in modifying the size of the buffer, then you have to do that before making any operation, meaning that doing any read or write or whatever you need to do on the file. And also you need to open the file first before you set the buffer. Okay, so I'll write it here. Let's say we use set v buffer, right? So now I want to set my buffer size to, let's say, a new size, right? So how we do that is that you declare a buffer, right, that you want to use as your buffer. So I'm going to use 214, right? I'm no more going to read this because it's no more important, right? So I'll take that out. Now I will open this in write plus mode. Let me read it. It's not really a requirement, but then I'm just trying to. Now seeking, I won't need that. So now if I want to set the buffer size, that's how I'll do it, right? Now I'll write to the buffer again and then see what will happen. Okay, so let's set the buffer size to we are setting the buff to buff. Okay, so this is supposed to be an array of size, not that. So all right. So now what I'm doing is that I want to set the buffer to this side, and then I have the modes, right? So the modes can either be IO. So as I said earlier on, you can either make it fully buffered, line buffered, or unbuffered. But I'm going to make this one line buffered. So we have the line buffered inside this one. If you wanted to make it, let's say, full buffered, it's IO, full buffer. So full buffer, and no buffer will be N buffer, no buffer NBF, right? But then in my case, I want to make it a line buffer, so I make it IOLBF, and then the size of buffer, which is 1024. So now I'm setting my buffer to this size. Now let me recompile this one. Okay, I think I have over here, so let's see. So sorry, so this was supposed to be FOP, and then what again? So let me see if right. So so this is not supposed to be there because there's a static buffer. This is now stored on the stack, so we don't need to free it. So now, okay, so the error that we are getting isn't really important because I can take it out because I'm no more using it. Let me just comment it out, and then that should compile fine. All right, so now I can use GDB to, let's say, have this one. Then I have, now let's break at 13, and then let's see. Now when we run this program, all right, so if I print my buffer, let's print my file descriptor and see what is inside. You can see this, right? Now you can see now our buffer is no more pointing to what we were seeing previously. Now this is the buffer that I created, right? Now imagine if I had initialized this, if I had initialized this to, say, to 0, you would have seen zeros over here, right? Now I didn't initialize, that's why we are seeing the gibberish data inside here. But let's do that and see what we'll get. So let's say I have this one, and then I break at 13, then I run. So now running, then I print first. So we can see it's giving us an empty string, right? Because I initialized it to 0. So basically that's how it is working, or that's how it works. Yes. Well, if you don't believe me, you can use the S command to analyze what is happening on there. So we can use this one and then print, let's say, G, and then print how many characters? 120. So let's say 120 divided by let me print 100, and then the address of the buff. So this is supposed to be, the 100 is supposed to be here. So you can see everything is 0. So the content is 0, as you can see over there. More that you can find about file streams, which are very helpful in C programming. Thank you.